So we have to integrate 1 by cos square theta into tan 2 theta plus sec 2 theta d theta. Okay. So the idea is, you know that you have to use substitution. Okay. And majorly if you will take help of substitution, uh, you have to take something as z, correct now? Now look at this. Do you remember that while handling the chapter named trigonometric equation or trigonometric ratios, do you remember? Over there we guys have studied so many formulas, and we guys, among those so many formulas, we have memorized so many formulas with respect to tan. Okay, like tan 2 theta, sin 2 theta, cos 2 theta. These all formulas we have memorized with respect to tan, correct now? So why we have memorized that day in terms of tan, you will understand in this chapter. Okay. So what I am suggesting you guys, just convert this question into, just apply the formulas. So can I replace this cos square theta as 1 by sec square theta? So it is sec square theta d theta. Correct? Now can you apply formula of tan 2 theta? So it is 2 tan theta upon 1 minus tan square theta plus, can I write this sec 2 theta as 1 by cos 2 theta? Now do you remember cos 2 theta was what? Cos square theta minus sin square theta. Okay, we have to convert them into tan. So what I'll do, I'll divide, like on denominator if we have nothing, can we accept 1? है ना? So now can I replace that 1 with cos square theta plus sin square theta? Now divide numerator and denominator by cos square theta. So it will become tan square theta upon 1 plus tan square theta. Correct? Now apply the replacements. So it is sec square theta, and then we have 2 tan theta upon 1 minus tan square theta plus, this thing will become 1 minus tan square theta and 1 plus tan square theta. Correct? Now this is d theta. If you'll observe this part, you will feel like denominator is same, so numerator will be simply added and you will have a square plus b square plus 2ab. So can I write that thing as sec square theta, this is numerator, and the denominator is what? 1 minus tan square theta LCM, so that will come in the numerator. So 1 minus tan square theta. Now we have the LCM as 1 plus tan theta whole square, है ना? And then we have d theta. Now can I write this element as a plus b, a minus b? So we will have sec square theta 1 plus tan theta 1 minus tan theta. Okay, and the denominator is 1 plus tan theta square. So one thing will get neutralized. Okay, so we are left with sec square theta upon 1 minus tan theta and then 1 plus tan theta integration d theta. Okay, now look at this. You know that we have memorized all the formula with respect to tan. For time being, take z as tan theta. You will understand here something, and that something will be super important. So suppose that you have taken z as tan theta, so dz by d theta will become what? Sec square theta. Okay, so whenever you are handling trigonometric integration, try to convert your question into tan, and you have to take tan as z, and then do the differentiation and try to create sec square theta. Okay, your things will be done. Now apply the replacements. So after replacements, you will be having 1 minus z upon 1 plus z, and this thing will become dz. Why? Because this d theta and sec square theta will become z, dz. Okay, now it is linear by linear, correct now? So can I break this question into two questions, that is dz by 1 plus z minus z and then dz 1 plus z. Now look at this, we have to integrate this function. So what I am suggesting you, just add 1, subtract 1, and you will find out that this question becomes very easy. So dz by 1 plus z minus z plus 1 by z plus 1 dz, and then minus of minus will become plus dz by 1 plus z. Correct? So can I say that first component and the last component are same? So it is 2 times. So can I say that like suppose what is the integration of this thing? You can treat this thing as dx by x. So log x, instead of writing x we will be writing 1 plus z, and here also we will get the same thing. So can I write 2, and this thing, so this thing will be neutralized, we have to integrate dz, so that is z plus integration constant c. Now what you have to do, you have to apply the replacements. So you have to replace z. So you will replace z with whom? Tan theta. Look at your z, z is here. So the required answer will become 2 times log 1 plus tan theta, bracket close, minus tan theta plus integration constant c. I hope the idea is clear, and from now onwards whenever you will witness trigonometric integration, you have to convert your question into tan, and then you have to take tan theta as a z and try to create sec square theta. Okay.